to solve some of the interesting problems actually. So for example, so here's one example. Imagine it is known to me that I have, if I integrate this function f of x dx, I don't know what this function is, but the thing that only I know is that, okay, it starts from 0 to 10. Okay, so before that probably I must write another property, the last property. Okay. And this last property is, so this is property number 5. Property number 6 is that if you have an integral a to b f of x dx, so you have like this interval a to b, and say there is a point c in between a to b, then you can integrating a to b is same as that you integrate it in the interval a to c and c to b and sum these two integrals. So in other words, integrate from a to c f of x dx plus integrate from c to b f of x dx. Okay? So even you can break the integral into two parts. I mean, if you have a point c between a to b, so integrating from a to b is same as that you integrate from a to c and then c to b. Okay? And then c to b. Now, here is one little example that I must do. For example, it is known to me that I have a function that goes from 0 to 3. I don't know what this function is, f of x dx, but its value is 5. This is known to me. And I have another integral that goes from, say, 0 to 3. Okay? And g of x dx, and its value is minus 2. Okay? And now I ask from you, what is the value of the integral from 0 to 3, 5 f of x minus 2 times of g of x dx. So if you know these two values, that the integral of f of x from 0 to 3 is 5 and integral of g of x from 0 to 3 is minus 2, then what is the value of this integral? Okay? So in order to compute, in other words, 5 times of f of x minus 2 times of g of x. So in order to compute this integral, I can apply the properties. The first property is that, okay, if you have sum of two functions, integral, this is same as that you are difference, that take the sum, or take the integral, take the sum, sum or the difference of the integrals. So in other words, I can write this as 0 to 3, 5 times of f of x dx minus 0 to 3, 2 times of g of x dx. So this is what, if I applied the first property. Then I can apply what? That if you have a constant multiplied by the f of x, you can pull that constant out of the integral. So I can say that this would be now equal to, so if I pull this 5 out, it's going to be 5 times of 0 to 3 f of x dx, and if I pull this 2 out, minus 2, 0 to 3 g of x dx, so this is equal to, now I can substitute the value of integral actually. Okay? Now I can substitute the value of integral. So the value of integral of f of x from 0 to 3 is 5, so it's going to be 5 times 5 minus 2 times 0 to 3 integral g of x dx is, what do you call, minus 2. So it's going to be 25 plus 4, so it's going to be 29 actually. So the value of this integral, if you have been given other parts, is really equal to 25. Okay? So this is what really is the values of the integral actually. Now I will really tell you. So we have seen that okay, the integrals are pretty crazy to compute by, for example, this limit sum. Now I would like to give you what do you call a result that is going to make your life very easy if you want to compute the integral of the integral of any given function. It's going to make your life hell easy. Okay? It's going to make your life hell easy. So here is a theorem which is called the fundamental theorem of calculus. It's called the fundamental theorem of calculus. So when you're going to use this theorem, you're going to say, okay, thank you very much to the fundamental theorem of calculus because it has made our life easy. I don't need to compute the sums and limits, and I don't need to split what do you call the intervals into the what do you call subintervals, and you don't need to do anything of these actually, and you can directly compute the integral of the given function. So how to compute the integral of given function? So if you have a function f that is continuous, okay, you need continuity on the interval a to b, okay, then if you want to compute the integral of f of x a to b dx, so if you want to compute the integral of f of x a to dx, first do what? Find the antiderivative of f actually. So what you need to do? Find the antiderivative of f. Say capital F is the antiderivative of say small f, and then evaluate this antiderivative at upper limit first minus then lower limit. Simple. Okay. So what you need to do, if you want to integrate a function, okay, over the interval a to b, find the antiderivative of this function and then substitute the upper limit minus what you call lower limit, and that is going to be your integral. And yesterday we saw that how easy it is to compute the antiderivative actually. Okay, it is not difficult to compute the antiderivative. So I have, say for example, x square dx that I want to integrate from 0 to 1. That I need to integrate from 0 to 1. From our first complicated example, we know that its answer is 1/3 actually. So we calculate the Riemann sums and calculate complicated limits, and we came up with this simple result. So what you need to do now? So first you have to find the antiderivative of the integrand. What is the antiderivative of the integrand actually? The antiderivative of the integrand, so what is the antiderivative of x square? So we yesterday learnt actually that the antiderivative of x power n is x power n plus 1 upon n. So the antiderivative of x square is going to be x cube or x cube upon 3. X cube upon 3. And now evaluate this antiderivative first at the limit 1 and then at the limit 0. So this is a way to say that first substitute the limit 1 and then substitute 0. So let's first substitute the limit 1. So you're going to get what? 1 cube upon 3 minus 0 cube upon 3. So 0 upon 3 is going to be 0, 1 cube is going to be 1 cube, so you got 1 over 3. So very simple. Okay? Very simple actually. Let me recall the list for you. Okay, let me recall the list for you first, and then so for example, if I have to find the antiderivative from 1 to 3 of e to x dx, integral of e to the x from 1 to 3 dx. So my f of x is e to the x. So what would be the antiderivative? The antiderivative of the function is a function whose derivative is equal to this small f actually. So I want to find a f. If I derivate that f, I must get what do you call this f of x actually. So what is the antiderivative of e to the x? So it is e to the x. Because if you differentiate e to the x, you're going to get small e to the x actually. So 1 to 3 e to the x and dx is going to be e to the x, substitute the limit 1 to 3. So in other words, e cube minus e to the 1. So this is what really is the answer. So see, you can compute all kind of definite integral through what do you call the antiderivatives actually. Okay. To make our life easier, let's list, for example, the antiderivatives. And let me introduce a notation which is indefinite integral. Okay? Indefinite integral. Indefinite integral. So it's an integral without limits. So it's going to be a function. So I'm going to say that if you want to integrate a function f of x with respect to dx, when I'm saying that integrate a function f of x with respect to dx, what actually I am saying is that find the antiderivative of this small f of x. So whatever is the antiderivative of this small f of x is going to be, okay, is going to be the value of this integral. So the output of this is going to be, what do you call, an f of x. Okay, f of x plus c, where okay, it's going to be f of x, where f prime of x is equal to, what do you call, f of x. Okay, so the integral of some given function is a function whose derivative is this integrand. The output of the integral is going to be a function, the antiderivative capital F of x. And what is this capital F of x? It is the function, if I derivate this function, I must get. So when I am saying that I want to find, say, indefinite integral of a function, what I am saying is that this function is derivative of what? This function is derivative of what? So this function is derivative of whatever is going to be the value of integral. Is going to be the value of integral actually. Let's do this some, what do you call, some list based on it actually. Let's do some list based on it. So first you need to keep this property as well, that you know what is the antiderivative of f of x plus g of x. The antiderivative of f of x plus g of x is the sum of the antiderivatives of f and the antiderivative of g of x. In other words, I can also write it that if you want to find the antiderivative of f of x plus g of x, find the antiderivative of f of x plus find the antiderivative of g of x. Okay, this is what really is the case. The basic properties, the sum property. Now, what is the antiderivative of x power n? So whenever I am saying that what is the antiderivative or the integral of x power n, what actually I am saying, what is the function to which if I differentiate I get x power n. So it must be what you call x power n plus 1. But if I derivate x power n plus 1, the trouble is going to be n plus 1 multiplied by power n. But I want only x power n. So I need to divide by n plus 1 plus the constant c. So this function is antiderivative of x power n. Okay? Antiderivative of x power n. What would be, say, antiderivative of e power x? In other words, what is the function to which if I differentiate I get e power x? The answer is that is e power x itself. Okay. What is the function to which if I differentiate I get sine x? Because this symbol, you have to make sense of this symbol. Read it as, so integrating sine x with respect to dx means what is the antiderivative of sine x? In other words, what is the function to which I derivate and get sine x? So I know that if I derivate cos x, I'm going to get sine x, but that would be a minus sine x actually. So if I derivate minus cos x, it's going to be plus sine x actually, because the derivative of cos x is minus sine x, and that minus multiplied with minus is going to be plus x. So the antiderivative of sine x is what do you call plus cos x. And similarly, integral of say secant square x dx is going to be what? It is the antiderivative of secant x square x is tangent x plus c. Why? Because if you derivate tangent, you get secant square. Okay. What is the antiderivative of 1 over 1 plus x square dx? You're going to say this is tangent inverse x plus c. Why? Because if you derivate tangent inverse x, you get 1 over 1 plus x square actually. Okay. So computing the integral is not a difficult thing. You can calculate it like very easy. Similarly, what is the antiderivative of 1 over x dx? You're going to say this is equal to log x plus c. And so on and so forth. So there's a list of integrals which is there actually. Now, let's calculate, for example, as an example. Let's calculate, say, antiderivative of 10x power 4 minus 2 secant square x dx. Okay, 10x power 4 minus 2x square dx. By the way, it is like the definite integral. There is also a property that if you have a constant multiplied by f of x dx, then its antiderivative is the antiderivative of f of x multiplied by c plus the constant. So if this is a, you can have a times f of x plus c. Okay. In other words, you can pull that, or maybe I say that pull the integral out of what do you call integral actually. So in other words, if you have a multiplied by some function times integral of integral, then you can take that constant out and integrate first, and then so in those antiderivative of a times of f of x is equal to a times of antiderivative of f of x actually. Okay, so that definite integral is really antiderivative. So if I have to do this, what would be this? So I can apply this property. First, let's find the antiderivative of 10x power 4 dx. Let's find the antiderivative of 2 secant square x dx separately. So this is like this constant, so I can pull this out of integral. You're going to get x power 4 dx minus, I can pull this constant out and you're going to get secant square x dx. Now what is the antiderivative of x power 4? So we know the general formula that x power n is, the antiderivative of x power n is x power n plus 1 upon n plus 1. So it's going to be 10 times x power 5 upon 5 minus, this is going to be 2. So what is the antiderivative of secant square? So it's tangent x. So 2 tangent x plus constant. So you can say this is 2x power 5 minus 2 tangent x plus constant is the antiderivative of this 10x power 4 actually. Okay? Is the antiderivative of 10x power 4. Okay. For example, if I say that now find the value of 0 to 3, say x minus 6x cubed dx. So this is like if you have to find a to b f of x dx. So first find the antiderivative of f of x, which is capital F of x, and then substitute upper limit minus lower limit, f of b minus f of a. So the first step is really to find the antiderivative of this x minus 6x cubed dx. How are we going to find? Always try to break down your integral in the terms of these basic integrals actually. Okay? Simplify them as much as possible and then apply this antiderivative list actually. So I can say, I can do 0 to 3x dx minus 0 to 3 6x cubed dx. I can go one step ahead. So what would be the antiderivative of this? X, so it's going to be x, maybe like I can write a one step ahead. In other words, I can take this 6 and pull this out actually. And then I can do the integral. So this is going to be x square upon 2, substitute the limit 0 to 2 minus 6. This is going to be x power 4 upon 4, substitute the limit 0 to 3. Okay, so you see how easy it is to calculate really the integrals actually. You don't have to get into all these sums and all that stuff. Then substitute the values. You're going to have 2 square upon 2 minus 0 square upon 2 minus 6, 3 power 4 upon 4 minus 0 power 4 upon 4. Just calculate this number, and this number is going to turn out to be minus 6.75. Okay.